to an introduction to the Rust programming language. My name is Brian Sletton. I'm coming to you from Northern California, where the world is quite literally on fire. So if I have a coughing fit or sound a little funny, I apologize. There's a lot of bad stuff in the air outside right now. But I hope things are better where you are and that you are doing well. This is exciting that we have the opportunity to get together and still chat about new technologies and emerging trends in our industry, despite everything else that's going on. And it's great to be part of the Microsoft Reactor program. This is a set of facilities around the world that are meeting spaces for developers and startups and meet up people to get together and exchange ideas and to talk about new technologies. And I encourage you when things calm down in the world that you if you haven't been to one, you give it a chance, because there's a lot of really great exchanges. I've done some in-person sessions in Redmond, and hope to be able to travel and get to see some of the other ones as well. So in any case, it's great to be part of this webinar series. Today we're going to talk about the Rust programming language. This has emerged in the last several years as one of the most popular programming languages with developers. And it's something that I didn't really pay attention to for a while. I mean, I was aware of it, but I kind of just put it in the same space as Go. And being sort of a old school Unix dude, I had sort of been drawn to Go initially because of Ken and Rob's involvement. But I'm also very interested in WebAssembly. I'm currently writing the WebAssembly definitive guide for O'Reilly. And several years ago, when I first heard that Rust was emitting WebAssembly natively, that surprised me, because up until that point, I'd only done anything with the C and C++ tooling. And that was when I realized that Rust was LLVM based, meaning that it has the pluggable front end, the mid-level sort of optimization layer, and then a pluggable back end. And Rust has always supported this, so it's been able to be a cross-compiling language. On Windows, you can compile with the right tooling installed for Mac OS or something, or an embedded system. And to that extent, Rust, with its support for WebAssembly, just had to add a new backend to emit that. So that's what originally got me interested in Rust and looking at it. And after that, I became quite interested in it. I love the syntax. I love the language features. I love the approach to it. As somebody who's done quite a lot of security consulting, I appreciate the fact that it feels like we have a reasonable contender for replacing C and C++. Many programming languages maybe are easier to use or easier for developers to be more productive in, but there's a trade-off in performance. And so a lot of our high performance systems or safety critical systems and things like that have had to be C and C++ based for the performance reasons. But now we have a strategy where we can use a language that's also safe and doesn't run into a lot of the runtime issues that C and C++ have. So Rust really is sort of a nice balance between performance and safety, but it's also couched in an extremely modern ecosystem of tooling. They've got a very developer-friendly approach to documentation. The compiler emits really nice, really nice warnings and errors that speak directly to the code that you have and make suggestions in places. So there's a lot of reasons why you should want to be able to get into it. And we're seeing a lot of momentum around Rust. Historically, it has been used for more open source software, but now we're seeing companies like Microsoft and Dropbox and Yelp and NPM and a bunch of other ones. Even Apple's hiring people with Rust backgrounds. So we're seeing a lot of interest emerging in the commercial space as well. That being said, it has a rather large learning curve, and it's not unnecessarily so. I think I sort of liken it to, and I don't mean this in any kind of condescending way. To me, like, we treat JavaScript developers like we treat teenagers. Like some teenagers are very mature and responsible, and some teenagers kind of like slack off and get away with stuff. The JavaScript environment is very sort of forgiving. It doesn't really have a lot of expectations of how the developers are going to behave. And so it's really up to you to decide whether you're going to have the discipline to be sort of mature and whatnot. Um, Rust kind of forces you to mature, forces you to be an adult and to communicate about what your intention is. And that is a little bit painful, right? There are things that you won't expect that it'll be like, hey, you can't do that. And so that can be a little bit off-putting. But if you look at the developer satisfaction surveys, like once you get past that, just like once you kind of become an adult, it's kind of fun to be an adult, right? You have more freedom and you get used to the expectations of you. So, like I said, I don't mean that in any kind of condescending way. It's just it's a process where you kind of have to change and grow into the role, and the Rust compiler and the rules and everything sort of helps you do that. And once you do that, then it's able to transfer things that are maybe historically runtime errors into compile time errors. It's like, as long as we're communicating, let's be clear about what's going on, and therefore we can figure out how to move forward. And so that what I would say is probably the biggest strike against it. Historically, it has also been tooling. The development debugging experience hasn't been great compared to other languages, but the good news is we're seeing a lot of advancements there. The extensions for VS Code are quite nice, and I'll show you an example when we get to this writing a command line app section about debugging with Rust. But I want to start with just focusing on the language and things like that, things that will be of interest, things that will seem familiar, things that will seem a little bit unfamiliar. The biggest source of most of the pain for new Rust developers is the memory model, and particularly the notion of ownership transfer, borrow checking, those sorts of things we will touch upon briefly, but in a short class like this, we really can't get into it too much. But I want to highlight where you'll run into those kinds of things as well, and why it's there. But at the heart, right, Rust came out of a side project that Graydon Hoare did when he was with Mozilla, and people started to get interested in it. It became sort of supported by the Mozilla project. They wanted to find a way of replacing certain portions of the Firefox renderer, like the servo engine was written in Rust. And what they found was the experience was very pleasant and produced high quality results and high performance results. And so that kind of gained some momentum in terms of the resources that they were willing to throw at it. Their recent financial issues have shifted their focus a little bit, but they're still very much interested in Rust evolving and becoming what I think it is likely to become in terms of how widely it's used. I've done some training with customers who had committed to Rust as their development stack, and we're quite happy with these things. So, in any case, I'm glad you're here, and I hope that you are excited about learning some more. So, what is Rust? It is not an object-oriented programming language. So it doesn't have things like class inheritance and in the same sense that you would expect, but it does have features that allow you to emulate a lot of those features. It is a very high performance system, right? It produces very optimized code, and that code can be optimized in lots of ways, depending on the target environment. That's one of the benefits of being based on the LLVM toolchain. But it's also got design principles in it that are similar to C++'s in the sense that they're called zero-cost abstractions. If they introduce something new to the language, they generally want to have that not impact people who don't use it, right? So there's no real overhead to adding something to the language for features that people, whether they use them or if they don't use them. It also has very little overhead from a runtime perspective. Historically, with C and C++, you have complete power. You have complete freedom in terms of what you can do. The runtime is very forgiving in terms of what it'll allow, and casting things from one type to another. And that's where a lot of the speed came from. But that's also where a lot of the security and safety issues come from as well. And so what Rust is doing is saying, I'm not going to let you get away with as much, but I'm not going to go all the way to what the Java world did and languages like that, which was to say, look, you don't have to participate. You can just do it and I will figure it out. So the garbage collector with Java made it a lot more, friendly for developers to be able to allocate memory and then not have to worry about freeing it up because the garbage collector will keep track of it. So they had to invent all these, convoluted schemes for keeping track of when something is being used and if two things in different threads allow for the access to the same part of memory. So they need to keep track of strong references and weak references and phantom references. And all of that overhead is really sort of shifting from development activity into runtime activity. And for long-running things that in the background, that's not necessarily a problem, but for performance-critical things, for safety-critical things, we can't just have this garbage collecting thread kick in unexpectedly, and so the thing that we need to happen, get thwarted. We've got a question if Rust is the new Java, the new generation. It's certainly influenced by Java, and particularly with the WebAssembly backend, Rust code can be made even more portable, I would argue, than Java is, because Java only runs on the JVM, and the JVM only really runs on computers and, a handful. I mean, obviously Android, but doesn't run on iPhones, doesn't run on iTablets or iPads, doesn't run in a lot of environments like that. And Rust will be able to run in all of these things. I would say the target is slightly different, right? Java targets generally application development, whereas Rust is sort of a system engineering language, more like C and C++. But that's not a hard boundary, and I fully expect that we're going to see Rust being used in more application development. So I think it could serve a role that Java has served in the past. We're seeing it being used for multi-threaded code because of the safety around the memory model. We're seeing it being used for microservices increasingly because it has a nice, low overhead, fast response time. But I would say, arguably they have a slightly different focus going into the conversation, but I think in the middle it gets a little muddy in terms of exactly where and how it'll be used. But I certainly am more interested in Rust than I am in Java these days, and I've been using Java since the hot Java days. So that's where I intend to do a lot of my work. The memory safety is one of the real reasons why I like it. And basically, if a variable points to some heap allocated space, then nobody else can own that. Only one variable can own a portion of memory at a time. And so if you assign a reference to, say, a heap allocated string to another variable, ownership transfers at that point, and the first variable can no longer use it. And that seems a little heavy-handed, but that's also true if you say pass a string into a function, because I don't know what you're going to do on the other side of that function. Therefore, I can't reason over what you're going to do on this side of the function afterwards. So in order to use a reference, you'd have to pass it back. And so that memory safety comes from the memory model and this ownership transfer process. Now, that's an awfully heavyweight burden. So usually what that encourages you to do is if your function that you're passing the code, the reference to, doesn't actually need to modify the code, the data, then what you'll pass in is a reference, not the actual memory. So that's what we call borrowing. It's not actually transferring the ownership. And so that then encourages you to design APIs and functions and code that works well in that space. And then the net effect is the code is a lot cleaner, more explicit. The compiler can enforce certain invariants. And at that point, it can take care of the cleanup, right? In C and C++, you have to do everything. If you forget, it's a problem. In Java, you don't have to do much, but that results in a large overhead at runtime. With Rust, if you're clear about when you're done with something, if there's lexical scoping and a variable goes out of scope, then Rust can say, aha, at this point, I can deallocate the memory that's associated with it because no one else can own it. No one else has the ability to point to it. And so what happens then is we have no stale references. We have no ability to reference something that's been uninitialized. And that's where the memory safety comes from. So that will trip you up. I promise you, dozens of times before you get comfortable with it. But once you do get comfortable with it, you'll just write code that sort of works in those expectations, and it will become a lot more natural. And so that's where I think the sort of dissonance between the steep learning curve and how happy Rust developers are after they get past that is they just learn to write better software that's more predictable, and then you and the compiler are working together to produce high quality, high performance software that is not fragile like C and C++, or have this heavyweight overhead runtime of the Java space. It is statically typed, but like I like to say, the goal is to type things, not to type things, in the sense that, we want there to be types in the ecosystem, but not be really annoying about how much you have to type. And so where possible, as you'll see in a moment, it is able to use type inference. And, if you leave breadcrumbs, it'll figure it out. But you can also be more explicit if you want to. Why should you be interested in it? Like I said, it's really popular with people who've gotten past that learning curve. The community is very open and encouraging, and there's just a tremendous amount of books and documentation and tutorials and things that are available. And it's really possible to build high quality, high performance systems of varying nature. And then again, with the association with WebAssembly, that can then be very portable and can run inside the browser, run outside of the browser, run in Node, run in Dino, run in external environments like WASI, Wasmer, and Wasmtime. People are writing operating systems in Rust. They're working on device drivers. Microsoft is updating portions of Windows in Rust instead of C. Because of the low overhead at the runtime, it's very useful with embedded systems. And so, the more that we're doing with Internet of Things devices, the more things that we're doing with sort of embedded environments like Microsoft's Sphere. I forget what their IoT, I think it's Azure Sphere is the IoT device, or like the Jetson Nano stuff from NVIDIA. Those kinds of environments will perform very well because there's not a huge runtime overhead expectation. I'll go over some of these links after we have a chance to talk a little bit more, but these are some things that are available. We've got a link to the slides that we're going to have in the chat room for this session, and the video will be available as well. So I'll come back to these, but we have courses and books and tutorials and things that will help you dig deeper into the language than we'll have time to deal with. So let's go ahead and start. As I go, if you have questions, please put them into the chat, and I will try to get to them as soon as we can. So let's start with Hello World. It's unsurprisingly our first example. And in this, you see that there's fairly low ceremony required for having a functional Rust program. We have a function definition called main. If we aren't going to use the variables, then we don't need to declare them. If we're not going to do anything interesting with the return type for this function, we don't need to deal with that. And then we can just have it print out the familiar string. Now this looks like a funny function call, like you're saying it with emphasis or something, or yelling print line. It's what's called a macro in Rust, and it serves somewhat the role of templates in C++. It's a code that generates other code, and so specifically to deal with formatting and dynamic things and things that have a lot of overhead, that's a useful way of building and extending the language. So you'll see these exclamation points several times when you're getting into Rust. I'm not going to go into too much more about them, but it's a macro language for extending the language in interesting ways. Now, certainly you can install Rust, and what you'll want to do is to install Rust Up, which is a toolchain management system that I'll talk about a little bit more in a minute. But if you just want to play around with some of these examples or some of the Rust by examples, there's no need to install that. You can just work directly with the playground. So if you go to play.rust-lang.org, there is an online version that allows you to type Rust code into it and execute it. Now you'll notice some interesting options. Number one, you can run the code. You can generate the assembly, underlying assembly for a particular target. You can generate WebAssembly. You can have a debug optimized version. You can have a release optimized version. But you can also target one of the three what are called channels. So Rust is very, very interested in having stability in the ecosystem, if that's a goal of yours, but it also doesn't want those to be handcuffs to stop you from innovating with the language. And so there's also the ability to have sort of cutting edge nightly releases of things. So there's a stable channel that gets updated every couple months. There's the nightly channel that gets updated in theory every night and can break stuff. And then there's this beta channel that's in the middle that's not quite as potentially fragile as the nightly channel, but not quite as stable as the stable channel. And all you need to do is just to install those versions of the tools via RustUp. So by default, it'll install, I think, the stable for your platform, but you can also then add in the nightly support. You could add in support for Linux, for example, if you're on Windows or Mac OS. Or if you want to install support for WebAssembly. Those are just like tools that get plugged into the tool chain, and then you can decide what your default settings for these things should be. So with the playground, you can say, I want to execute this against the nightly version, the stable version, the beta version, and it will do that accordingly. So this is just one way for you to play around with code without having to worry about installing stuff up front. But if you do have the toolchain installed, then normally you'll use the cargo build tool, which is its own topic. It has its own book. But for our purposes, we're going to just use the rustc compiler. And we're going to take the code and compile it. Because it's got a main function, it's an executable. And if we run it, unsurprisingly, it says hello world. So that's just a quick introduction to the tooling and how you can exercise these things. The playground is not intended for all types of applications. Things that involve file manipulation or multiple threads or things like that are not going to be all that useful to run in that environment. But exploring language features, it's good for that. All right. So the next step, we're going to assign a variable, a value, and notice in this case we don't have to specify the type. You know, you may hear that Rust is very type specific and cares a lot about types, and it does, but by default it uses type inference to figure out what the X value should be. And so in this case we're going to print it out, and then we try to change the value and print it out again. And one of the things that will surprise you probably the first time you start playing around with the language is this will not compile. And if you stare at it, you think, what is wrong with this? This makes all the sense in the world. And it's because Rust's going in position is opposite of the going in position of other languages, which is, unless you tell me otherwise, everything's immutable. And that, again, is a design decision. It's not that we can't have immutable stuff, right? With C and C++, everything's immutable unless you tell it that it's not immutable with const and things like that. Here, we take the other approach. We're saying everything is immutable unless you tell me that it's immutable. And that will solve an entire class of bugs, where if you have sort of a longish function and you introduce a variable at the top of the method, and then you sort of assign to it incorrectly somewhere in a loop in the method, you may not notice that. That could be a logic error that you will not notice until runtime or until something goes wrong. With Rust, that just won't even happen, because it'll say, whoa, you can't assign to that. You didn't tell me that you wanted that to be mutable. So again, not a huge issue. Once you get comfortable with it, it's not something that's going to be any kind of impediment to you, but it's the kind of thing that you run into, and until you get comfortable with, will sort of surprise you a little bit. So we solve that problem by specifying that X is a mutable variable, and then it's we're able to change it afterwards. So that immutability plus the memory memory checking, ownership transfer, or borrow checking stuff, all sort of contribute to where the safety comes from, right? In terms of you just can't express something that will get into a funky, uninitialized, or double free kind of state. All right, so once we do that, then unsurprisingly, it will print out and we'll see what we expect to see. In terms of the types, everything that you expect to be there is there. It may have a slightly different notation. I actually really like these little suffixes of I8 and U8 tells you whether something is a signed or an unsigned data type of a particular size. It seems a little fiddly in particular. Like if you're used to just thinking about integers as integers and not their size, that's probably an indication that you've been working in an environment like Java that's targeting applications as opposed to sort of system things. In system languages, you want to be very particular about how you encode stuff because that has to deal with how things get laid out in memory and how much space things take up. So a U8 is effectively a byte. But one of the next things that you'll run into with Rust is that there's no implicit conversion. So even in Java, you can convert bytes to ints and characters to ints and booleans to ints and things like that. In Rust, you can do that, but not accidentally or not, without being explicit about that being your intent. So you can also have literals. So if I had the number 10 and I followed that with an I8, then 10I8 is a literal. It's an integer literal, but it will be interpreted by the Rust compiler as an 8-bit signed integer, or if it was a U8, it would be an 8-bit unsigned integer. So we can have types even amongst our literals in a very clean sort of compact syntax if you want to. There are defaults, right? So by default, F64 is the 64-bit floating point number is the default because most modern systems these days are 64-bit architectures and there's not a tremendous overhead to having that be your default precision. But if you need to specify it, then you'll notice that it's a suffix, a postfix type as opposed to a prefix type in other languages. So we would say, let y be interpreted as a 32-bit floating point number, even if you might otherwise come to that conclusion based on the defaults of the language. So in this case, x will be interpreted as a 64-bit floating point number, but because of the type annotation on y, we will the compiler will know what we intend it to be. Now this type inference follows from other operations and gets carried through. So 5 plus 10, obviously those will be unsigned integers, and those integers will be assigned to the value. The floating point numbers and their precision of 64 bits will be assigned here. So it's not just a singular value. It's like the expression carries the type annotations forward, the implicit ones, based on the inference of what's being used. Same thing for Booleans and characters, and likewise, if you want to specify that something is a Boolean, you can do that. But otherwise, just assigning a Boolean value to a variable is enough for the Rust compiler to figure it out. Now, it even gets pretty sophisticated in terms of type inference around generics. Rust has really nice generic support. And so, for example, if you're returning a vector of U32, unsigned 32 ints, if the function returns that, and then the last expression in your function is a reference to your data type, then it will assume that that is a U32 based version of the, say, vector, and therefore the inputs should be interpreted that way as well. So the type inference can be quite powerful, and so that gets back to my assessment that the point is typing, not typing. We want types to be there and to be visible and exploitable for safety purposes, but not just to be annoying and make you have to type what everything is. So I think it strikes a really nice balance on that front. We also have really nice modern support for things like tuples. So I don't remember the first time I came across a native tuple implementation. It's probably Python. But we've seen this in other languages as well, where it's just a lightweight way of associating some state for some intended purpose. You'll see this often in API designs. If you're talking about like plotting something on a graph, you might want to accept a point, and rather than have two separate variables that are sort of disconnected in their life cycle or whatever, you can have a single tuple that has the 2 points in it. And so you can pass it in as a single thing, you can return it as a single thing. So there's no point in creating a class or a structure or something just to hold this if its whole purpose is just to collect a couple of heterogeneous values. And so you can either use the native default types, or you can specify which types you want to be associated with the positions. Once you do that, then that type inference is maintained. If we were talking about heap allocated strings or something, this would trigger the ownership transfer, right? If you had a string that was owned by a variable and you want to pass it into a tuple, well, then the tuple would become the owner of the value, and the string would no longer, the variable holding the string would no longer be considered valid. So again, these things kind of creep into the process when you assign variables, when you pass parameters into functions, when you return them from functions, when you deal with data structures like structs and tuples. That's where it gets a little bit tricky. If you have a tuple, it's very common, like say a tuple return type from a function, you may want to destructure it and pull the pieces apart. And you'll see here that the syntax is surround the variables that you have with the parentheses, and the first position will be assigned to the first variable, the second position will be assigned to the second variable. And you don't have to pull them all out. You can only pull out the ones that you want, or you can refer to them through a positional index into the tuple as well. Arrays serve the purpose that you expect them to, but they're slightly different in the sense that they are fixed at runtime or at compile time. So they have to be fixed size. So in this case, because there are only 5 things being passed in, there will only ever be 5 elements of this array. Or you can assign them later, but you have to tell Rust how big you want the array to be, and so you would use a type annotation to say this is going to be a 5-element array of integers. Brandon asked, is there anything similar to Python's IntelliSense built into this? Specifically around debugging, I think is what you're asking. And yes, that's, as you'll see a little bit later, the extensions for, say, VS Code make it a lot nicer to tie into that. If you're using something like Emacs or Atom or Sublime, those tend to rely on something called language server. So rather than all of those details about all the languages that you might want to write in those various editors having to be encoded in those editors, we've seen the emergence of this concept of a language server that runs as a background process. And as you're editing the text, the tooling will basically pass the text to the language server, and it will annotate it with types and things that, and keywords for syntax highlighting and the kind of command expansion that languages provide. So if that's what you're asking, then yes, the tooling is getting better to support those sorts of things. Functions, again, on the surface, will basically operate the way that you expect. So we have a main function here. We invoke the printline macro that will print out our string. Then we call another function. So control flow passes to this function. We execute the code here. There's no explicit return type, but there is an implicit return type called the unit structure. And if you look in the chat, the unit structure is really just, in essence, empty parentheses. You could think of it like an empty tuple with nothing in it. And that's interesting because if I print, rather than this sum result here, passing in the value a, if I said another function and then called the function, what it would print out would be this unit structure. And so this is a way for the Rust compiler to tell if there is something coming back of the right type or not, without having to introduce nulls to the language, which is generally frowned upon these days. So once we're done executing this, there is no explicit return type, so there'll just be the implicit unit return type. Will come back here. We'll call the sum function. The sum function does return something, so we can see that we can express that this will be an I32, and when we add those together, that result then gets returned here and assigned to the variable. So we don't need to say that A is an I32 because it's picked up as the consequence of the return value, and then we can print that out there. So again, that's all fairly self-explanatory. This is not overly idiomatic Rust. Normally, you would just say x plus y, no let, no return, no semicolon, just the expression x plus y. And that's enough. The final expression in a function will be interpreted as the result. Just be careful. If you intend to do that, but you accidentally put a semicolon at the end of it, that turns the expression into a statement. Statements don't have return values, and therefore this will return the unit structure instead of the expected I32, and the Rust compiler will be like, hey, what are you doing? So you either have to explicitly use a return statement or just have a final function that's an expression that represents the return value. Control flow isn't all that different, although, for example, we don't idiomatically have parentheses around if clauses. You're encouraged to use curly braces around things just to be explicit. But notice if this were a heap allocated string as opposed to a string literal, and we had it in a variable in this main expression, then that would be an ownership transfer. And the same thing here, if we were passing it in here, that would also be an ownership transfer. But the Rust compiler is smart enough to realize there's no way that both of those clauses are going to get run. Therefore, that's okay. That's not a problem to have the ownership transfer twice, because there's no logical flow where that's actually going to happen twice. So again, there's interplay between control flow and memory transfer and variable ownership that plays out in things like this. In terms of loops, we've got a variety of structure. We have a loop like this will automatically start at the top, and it will continue until you break. So this is the kind of loop you generally want to do if you don't have an indexed or numeric or an iterator controlling the life cycle of the loop, and you want it to run at least once, then that loop structure would be the right thing to do. But you can write sort of more conventional countdown loops if you want. In this case, number is initialized to 3, while number is not equal to 0. We will continue to do our loop. But it's more idiomatic to use functional styles like iterators or maps and collects and the kinds of language features that have shown up in Java in the Java 8-9 timeframe and that are present in languages like JavaScript and Python as well. That's the more idiomatic approach to iterating over a collection of values. But beyond that, it's about what you would expect. So we don't have classes, but we do have structs, just like C and C++. You don't specifically add methods to structs like you do. You could have function pointers and things like that directly in C and C++. What you do instead is to have what are called impl blocks. So if I wanted to add a method to the struct user here in this case, I would have an impl block for the user struct, and then I could define one or more methods in there, and those would be associated with the struct. What's kind of cool is that you can extend structs that you didn't write, right? So you can extend things from other portions of the standard library or other people's code. So it's a very useful language feature. There are some rules that are kind of tricky. I'm not going to get into, but it really depends on where things are defined and where you're using them. You can't you can't extend something that you aren't using directly in a certain way, but like I said, once you get into the language at a deeper level, you'll run into those rules. So structs are really just collections of named values. It's got some really nice ways, so you can have sort of object literal type initialization of structs, like you see in JavaScript. You can have tuple structs that are defined just as collectors of values, so you don't have to create a whole lot of fiddly bits around the creation of these things. But it's just it's a useful way to co-locate collections of values of various types for modeling some kind of domain element. Enums are like they are in other languages, but one of the things that I really like about them is they can be stateful and they can be parameterized based on values. So in this case, if we are looking at a message handling portion of a game, say, and the user may want to quit, the user may want to move her character to a particular location, she may want to write a string out to the chat channel or change the color of the avatar's background or whatever. These can be defined as enums, so we're defining a fixed set of messages, and that fixed set of messages can then be reasoned over as a fixed collection of messages, and we'll see the value in doing so in a moment. But we can also leverage Rust's pattern matching capability, which is one of my favorite parts of this that we see in other languages like Scala. But we can match things like structs and enums and literals based on their structures, but also their values that are passed into those. So let's say that we wanted to have a handle message function, right? It'll take in one of our enums, and we can leverage the matching capability. And this is basically an in-order collection of patterns. And so for every pattern that's matched, we have this little arrow notation to say, what do I want to happen if that's the thing that's matched? And order is important here. But if we get a quit message, then we'll print out that the player wants to quit. If we get a move message, notice in the definition of the pattern that we're matching on, we are in essence destructuring the parameterized values to the message in a way that we can surface them to the code handling on the other side of the arrow. So once we introduce X and Y as two possible values that could be used here, then I can refer to them on the right side of the arrow, and that's a useful way of interrogating the state of the enums in this case. So we can do the same thing with message and the RGB colors. So why this is important? Matches are used all over the place. They're used for assignments. They're used as like very sort of compact, terse switch statements. But from a programming perspective, they reduce what's called the cyclomatic complexity of functions. If you've ever studied code metrics at all, cyclomatic complexity is a measure of the number of decision points, and those decision points, those put a cognitive burden on the developer, because you're like, okay, if this, but not this, but then this, but not this, but then this, it's harder to deal with. Here we're just saying, look, I have one input, these are the options, here's what I want to happen, and it's just a lot clearer, and you'll see really remarkably powerful expressions of behavior in a small, compact, easy to read, easy to sort of page into your head perspective. So in terms of using these messages, I can send a handle message with a message quit, a move message, the string that I want to write out to whatever the channel is, and the change of color. So unsurprisingly, if we just compile this and run this, we'll see these things come out the other side. That being said, I talked about how we are in essence creating a fixed set of collection values. And if we have code like this in existence, and we have 4 messages in our enum in existence, and say Brandon comes along and adds a new enum type. So he adds in a new message that we're not catching, then that's something that the compiler will enforce. And I'll show you that in just an example. But we can also match on the same message in multiple ways. Like maybe there's a special buff or bonus or something that happens when the player goes back to their home base. So in this case, I can match for a move to a specific location and then handle that differently than a move to other locations. And in that sense, this is a more specific pattern. So obviously we'll want to put it first. Otherwise, the Rust compiler will yell at you and say, that will never actually be, you never get there, right? Because the more general one will always match before the more specific one. But you can have some really powerful handling in terms of whether something is one value or not. If either side, like if I wanted to have special handling for a move to the x equals 0, I don't care where on the x plane it is or x line it is, I could say 0, underscore as a way of saying I don't care what the y value is. If the x value is 0, I want the special handling. And then I could have an underscore 0 to say I don't care what the x value is. If the y value is 0, I want this handling. And both of those would happen before the case in which that case would mean neither of them is 0, and the more general one would handle. So that kind of pattern matching is really, really, really powerful. And one of the things that I first sort of fell in love with Rust. So in this case, if I change my message to be moved to 0, 0 instead of 2, 3 and rerun it, you'll see that the player wants to move to home base. So in that case, it's enforcing the value-based pattern matching. But as I said, you know, if Brandon comes in and adds an enum for a new message, right, working on the ability to build a base somewhere in the game field, maybe specify the size or the power or how much energy you want to build into the base. This obviously is not a problem, right? We want to be able to extend the type collection that's in our enum. But think about this code that exists. We're not matching for this. And in other languages, that's just going to go silently unheeded because there's no sort of real notion about completion or completeness of the enum. It's just like, oh, okay, these are the only things that you're matching on. In Rust, that would be a compile error. If I tried to just add it and not change where I was matching on these things, then it would say, yo, you've got a new message type that you're not handling. Now, you don't have to specifically handle everything. There is an underscore pattern that means the equivalent of default on a switch statement. But the point is, it's forcing you to deal with the fact that you either need to treat it as an individual thing and handle it as an individual thing, or lump it into the bucket of everything else that you maybe don't care about specifically, but you have to handle it somehow, and Rust won't let you get away with not handling it. So that's the kind of thing that is really quite interesting and useful in that space. So I am going to switch over, if there are no further questions, and walk you through a more complete example. This is just a little command line utility. It accepts input from the user and tries to encourage the user to guess what number it randomly chose. So a couple things. At the top, so I'm using VS Code. In VS Code, I have the Rust plugin installed as an extension. And the code LLDB. So these two will provide the syntax highlighting and completion and things like that. So if I set up here, use standard comp, you see Brandon, it's filling in everything that you're expecting. That's absolutely the case that's going on there. We're going to tell it to use the standard IO library. Now, supporting strings and formatting strings and speaking to the console and all that kind of stuff, that's quite complicated code. And sometimes in embedded environments, there is no console. There is no way for you to print anything out. Rust allows you to use some annotations on your code to indicate that I don't want support for standard library. And so what ends up happening is that, there are certain things you won't be able to do in the code, but the generated runtime binary of your library or application won't have any of that support built into it, and it'll be much smaller. So again, even with something as simple as printing out to the console, you've got the ability to control whether that's a burden and a penalty that you're going to want your application or library to deal with. So we're going to say that we want to use standard I/O. Most applications will. This is pulling in these capabilities from it. You can highlight over it and you can see that it contains a number of common types that you'll need for input and output. We have traits in Rust. Traits are kind of like interfaces or abstract classes or something. It's a set of behavior that we can then expect from the structures. By default, structures that aren't trivial in their definition can't be printed out. You have to tell it whether you want it to have the display trait associated with it or the debugging trait. Now you can override what that means. You can add in methods in an impl block to have custom formatting and whatnot. But for the most part, that's, again, an example of the zero cost abstractions. Random number generation is not something that's sort of natively part of the language. These are considered features, right, of the language that somebody may or may not want to use. So there are trusted third-party libraries, and the rand package is one of the most commonly used ones. If you go to crates.io, it's sort of the equivalent of npm, you'll see that the rand package is the most downloaded one, and you can click on it and you can see the versions and everything. It'll take you to a book about random number generators. Like I said, this is all extremely well documented. But because it's not part of the runtime language, we have to specify it as part of our package definition. So whereas in Node applications, you might have a package.json, in a cargo application, which is, again, a similar structure, you would have a cargo.toml file. And in there, you'll see some metadata about the package itself. And then you can have dependencies. So in this case, we have a dependency on the rand package with version 0.73. So if I did not have that in there, then this would not compile because it would have no idea where to find the random number generator. But because I have it installed, notice it even tells us which version in my cargo home directory, in the cargo directory in my home directory. There's kind of the equivalent of like a Maven repository or a node modules directory. And in there, we have a specific version from GitHub that has been tagged and released, and that's the version of the library. So if you want to investigate like the code itself, you can see that we've got the hooks to get into that. The ordering enum is basically a way of indicating whether something is equal or lesser or greater than something else. So you can see that this, if you just highlight over it, it'll show you how to use it, where to go find more documentation. So if I want to compare the number 1 to the value 2, this would result in an ordering less because 1 is less than 2. 1 to 1 is an ordering equal, 2 to 1 is ordering greater because 2 is bigger than 1. It may surprise you that we're passing in a reference to a literal, but in this case, ordering is defined to be associated with references to things, because deciding whether one thing is less than another is not something that requires mutability. Therefore, by default, it's saying these are immutable references that I'm expecting you to give me. So again, this is just an example of how those guidelines that the compiler is going to push on you is going to have that kind of influence on how you design things. Let's see, Brandon says, generally I look for the most part in VBA, but I've been looking for a more robust language. How well does this compare to VBA? I would say Rust is quite a lot more particular about things than Visual Basic would be. I think you'd probably have a more natural flow into maybe TypeScript. I would say TypeScript is probably the most natural transition because it allows you to use JavaScript and all the JavaScript tooling, but provides types and type safety and whatnot during the development experience. So keep your eyes on the reactors. I did a talk last week on TypeScript. They may be scheduling some new ones in the future, but I think that's probably a reasonable approach. And the cool thing about TypeScript is through assembly script, that is a path towards WebAssembly as well. So if you want your code to run on Mac, on Windows, on Linux, in a browser, not in a browser, you have that path as well. All right, so we've got our imports, we've got our main function. We're going to call the gen range. Notice this is taking in a lower boundary and an upper boundary. This is what's called a half open interval. So it will only generate values between 1 and 10. So it starts at the beginning and goes up to, but not including the upper one. Normally in a game like this, you don't want to print out what the random number guess is, but just for debugging purposes, as you're working on it, you may want to see what that is. So then we're going to collect input from the user. So we need a place to put that. So we need to allocate a string, dynamically allocated string, for that by calling string new. And so this looks like a constructor, right? But it's not really a constructor in the conventional sense. It's a more of a convention that it's called new. But this is going to be where we're going to store the accepted input. So standard in is going to give us access to standard input. So this is where we're going to collect the value from the user for the current process. We're going to call the readline function. And notice it's going to, in this case, take a reference to a mutable string. That is where it will place the value that's read in. And then notice here, expect is a way of saying, look, things are either going to succeed or they're going to fail. And the way that we deal with that is to return an enum type of OK or error, right? So it's going to be one of the two. But if it's OK, then nothing happens, right? There's no need to have a try catch block. This is just a way of signaling in a syntactically clean kind of way. Something could go wrong here. And if it does, I want this to be the message that's associated with the error. So if there's an issue reading in the line for some reason, then this will raise a trap and it will barf and it will say, I failed to read in the line. So Rust doesn't have exceptions per se, but it does have ways of signaling where errors can happen. And I think a rather elegant way of handling this in the sense that it draws your attention to that something could go wrong here, but it doesn't force you to deal with it. So it's kind of like a middle ground between checked and unchecked exceptions in a language like Java. So at this point, we've read the function in, or we've read the string in. We've been successful. We've added it to the string that we allocated up there, and we printed out what the guess is. So the next thing that we want to do is we want to figure out, did you guess correctly? So we're going to parse the result. So first we're going to trim it. So if there's any excess white space, we'll get rid of that. Then we're going to parse it. And notice that the parse requires you to accept something that is convertible from a string, because what we're trying to do is to parse a string. Doesn't matter what it is, as long as it can be converted from a string, then the parse function can generate something from there. And obviously integers, literals, and things like that can be converted from strings. And then it returns either a result, and a result is either the thing that was parsed as a data type or an error. So again, we have our expectation. If you give me something other than a number, then we'll raise a trap and I will complain that you didn't give me a valid number. Obviously, there's more elegant error handling than just barfing and trapping all the time, but we want to go from there. All right. So then we have the pattern match, once I know that you've entered something, and it's been parsed correctly, then we have the three options. We have it's a less than, a greater than, or an equal to. So in this case, again, we're passing in a reference to the number, and if it's less, that's what we'll match, and we'll print it out. If it's greater than, we'll go too high. If it's equal, then we'll stop the game and we'll break out of the loop. So keep in mind we're in a loop to keep on going until the user guesses correctly. Anonymous asks if I like rusty spoons. Yes, I do like rusty spoon fingers. All right. So first thing that we can do is we can just run this as without debugging. If you go to, let me show this to you quickly. GitHub, Microsoft Reactors. Then there is a whole bunch of stuff, including some machine learning and data science and AI kinds of things. But there's also web development. Under web development, there's TypeScript and Rust 101. If you look under Rust 101, there's the cargo project predefined for you. A version of the slides, not quite the same. Hopefully we'll get you that link there. And within that, there is our main.rs file. Now notice, when I read this into VS Code, I just opened up that directory that the cargo TOML was in. And when you try to run it, it'll say you need a launch configuration. It will see that you have a TOML configuration, and it'll say, do you want to create one accordingly? So if we look at the launch.json that it generates, we'll see that it was able to generate this as an LLDB debugger using the launch mechanism, which arguments to pass into it, etc. So it created this structure for me based on the TOML file. So if I say run without debugging, down here in the terminal, we should see it pop up. So it guessed the number 10. Let's pretend I didn't see that. And I said 3, too low, 8, too low, 9, too low. Obviously, it can only be 10, and I win. Let's see the impact of the handling. If I run this without debugging, and I say guess a number between 1 and 10, and I say banana, notice that the thread panicked with a parse int error, and it said, please type a number. So if we go back to the code, we made it past the reading in the line, but we didn't parse it correctly. So this is where it ended up dying. And so we can tell that because we had a meaningful error message that would lead us back to it. But it also tells us that it was on line 20 in the code. So you can command click on that to go directly to that line. So that's, again, really nice debugging support, development support compared to what we have seen. Then obviously if you want to debug it, it will start up the debugger. We can go into the debugger. We can see that we have, at this point, read in. We've generated a random number. It's 10. We can create the new string. We can collect the result. So in this case, it's blocking for me to say 8. At this point, we were successful. We guessed 8. We can see what the guess is. Notice it even gives you visibility into things like the registers. So if you're doing some low-level stuff, you can see what the actual CPU registers are. You can step into the match and everything else. So we have a very nice, robust environment in VS Code with the Rust extension. But if you're more interested in Sublime or Atom, you can go to not are we GUI yet? Are we IDE yet? This is sort of a running Rust joke. Because of its open source nature, there's a little bit of a chicken and egg problem around some of the tooling and where these things show up. So these are just websites that you can bookmark and come back to see the status of certain things. So the one I was just at was, are we GUI yet? It's the state of building user interfaces in Rust. And so it'll walk you through various bindings to like Qt and QML and various other ways. So if you're interested in building a cross-platform application and you want to see what UI toolkits are available to you, that will help you. But if we go to are we IDE yet, you'll see that if you want to deal with Atom, these are the features that it has and how to set it up and whatnot. So VS Code is extremely nice, but there are some other options. The Sea Lion stuff from JetBrains is also a nice option for debugging. Okay, so let's talk about a couple of other things quickly, and we'll start with the website. The website itself has tremendous number of resources. It shows, how are people using Rust to build command line tools? How are people using Rust to interact with JavaScript through WebAssembly? How are they doing networking things? What you'll find is once you internalize the ownership transfer model and the borrow checking and things like that, then concurrent programming just falls out of that. It's really, really nice. It's really simple and easy because you don't get into the situation where two threads can point to the same thing in memory. The ownership transfer into the thread or into the method call on the thread or whatever you're doing is not going to even allow you to get into the situations that you can get into with concurrency in other languages. So a lot of low-level networking stuff, a lot of highly concurrent stuff, performs very well, and is also extremely safe and does a nice job there. If you're interested in embedded systems, working with Raspberry Pis or some of the new other boards that are coming out, you'll see a path towards that in the embedded sections here. Beyond that, there's the playground that I showed you, so you can go there. You can say, I want to build against the stable channel, the beta channel. I want you to generate LLVM intermediate representation or WebAssembly, or build it, test it if you want to have some test annotations in there. So a lot of useful things to learn there. In terms of the tools, they've got support for hooking into existing tool chains, but also they'll talk about Cargo, which is the build tool. There's tools for helping you format your Rust code. So if you want to have a particular style that makes it easy to read, that makes it easy to check in code because they don't have extraneous trailing spaces and things. The Clippy support is nice. It's a little bit like Microsoft Clippy in the sense that it's showing you when you do things non-idiomatically. So as a way of helping new Rust developers, Rustaceans as they're called, it looks like you're writing an iterator. Do you want some assistance in terms of doing that in an idiomatic way? And then to generate the kinds of documentation that we saw here, right, in terms of highlighting over getting all this kind of documentation. That's generally some annotations on the objects themselves. I mean, the classes, not objects and classes, structures and methods using Rust doc that make that kind of thing pretty straightforward. So good hooks into books on the tools and how to test things. The blog will keep you up to date in terms of what's happening. So, new releases, what's happening the next year, laying the foundation for the future of Rust, right? That kind of stuff is maintained in the blog. And then in the Learn section, this is just, again, the community really reaching out with open arms to new developers to say, I'm interested in helping you become a better Rust programmer. So the first thing is, if you go to read the book, you'll end up, I don't think I have it up, with this very comprehensive book, right? So it's got, an example of the guessing game and walking you through that in more detail, basic programming concepts, ownership, control flow, pattern matching, building projects and modules, dealing with collections, error handling, generics, tests, building command line tools, using the functional style of Rust, using cargo and crates, although there is an entire book on cargo that's available as well. There's a whole support for things like smart pointers to do reference counting and other sorts of sophisticated things that you'll be interested in for low-level sophisticated stuff. Fearless concurrency, doing OO-like things in Rust, more on pattern matching. Rust does allow you to do unsafe things. You just have to be explicit about it, right? So that's called unsafe Rust. And so you can do the kinds of casts and stuff that you would do in C and C++, but again, it's really up to you to be clear that you know what you're doing and to tell the Rust compiler, get off my back, I know what I'm doing. So then they'll walk you through things like traits and types and macros and building multi-threaded web servers and whatnot as part of a free introductory book that's quite remarkable. Now, the thing I'll point out here is that this thing flows with yeah, so it's just areweGUI.com. I think that's it. Yep. There's also areweML yet, I think. Nope, that's not it. areweAI yet? There's one that has to do with machine learning. There's arewe game yet. So if you're interested in Rust gaming and what people are doing in the Rust gaming community, there's a whole bunch of these arewe whatever things there yet. But I digress. So this is a fantastic book, but it's got the narrative structure of a book. As you're learning the language, you might be interested in like, how do I do this feature again? And all that sort of narrative flow might be more than you want to deal with. So that's where Rust by example, which if you go here, is this link. So Rust website, learn Rust by example. This just focuses on the language features. So if you're like, I want to focus on module creation or dealing with crates or setting attributes on code, it's much easier just to jump to a working code example. So in this case, generics. This builds up some generic stuff, and notice you can even run the code directly in the browser, and it will generally. Some of them don't work by default. You're supposed to tweak them, so this may be one that you need to modify to do something. But anyway, the point is, this is a much easier way to zero in on a language feature that you want to deal with, rather than like try to find the discussion in the book. And then the final thing, the Rustlings course. If you go there, you'll see that this will walk you through learning some of these things incrementally under the exercises. There are exercises for dealing with generics and dealing with control flow and working with macros and strings and structs. So a lot of interactive code tutorials that are available to you there as well. Beyond that, if you're interested in, say, Rust and WebAssembly, the Pragmatic Progs have a great book by Kevin Hoffman called Programming WebAssembly with Rust that will walk you through the integration of those worlds. But if you're also just sort of interested in general, if you go to rustwasm.github.io, I'm going to put this in the chat as well, that will take you through what's honestly one of the more fun tutorials I've done in my career. I did it a couple years ago, and you're building up Conway's Game of Life, but it talks about how do you call the JavaScript code from the Rust, and how do you call the Rust code from the JavaScript, and how do you do that efficiently, and then eventually gets into how do you have the Rust code rendering into canvases in a DOM, in a browser. So it's a really, really fun way of looking at how you can do web-based programming using this mixture of Rust and JavaScript. and things that make sense to do in a language like Rust, you can do in a language like Rust nicely. And one of my favorite examples, let me see if I can find it quickly. I don't have the link directly. Sudoku solver, there we go. Colin Eberhardt did this thing where he mixes OpenCV, TensorFlow, and a Sudoku solver with WebRTC in the browser. So he's got a WebRTC video stream. From there, he's getting the pixels. He's then using OpenCV and TensorFlow to identify the structure of the board and what are the givens. He builds a representation of that, passes it into a Rust Sudoku solver, which then solves the Sudoku, and then he re-renders the solution back in the images and the frames, right? That just shows you like what is it like to mix these things together in the browser, and how we can reuse existing code without having to rewrite everything in JavaScript if there's no need to, or if it's not going to be a good language from an expression purpose. So lots of very exciting things going on. I'm going to go ahead and switch back to the slides. If there are any additional questions, I'm happy. Could you use Rust easily in an Azure DevOps environment? Oh yes, absolutely. There's tremendous support within the Microsoft toolchain to interact with Azure DevOps capabilities and rolling these things out. That's absolutely supported there. If there are any other questions, please do feel free to toss them there. I am pretty easy to find on Twitter, so if you come across something later and have questions, please ping me there. Please do fill out the survey. There's a survey to see whether you like this or not, if you found it useful. They're interested in topics that you're interested in. So there's this ongoing collection of talks that are shared currently online only, but eventually will be in person as well at the reactors. And they'd really love to know what you think and what you're interested in. So if nothing else, thank you very much for your time. I hope you found it interesting. I hope it inspired you to dig deeper into Rust as a language. It's certainly one of my favorite new languages that I've learned in the last several years, and for most new projects that I'm doing, I'm relying on Rust for stuff like that if I can. It's pretty easy to do so. You can generate libraries that will function like C libraries. You can generate WebAssembly stuff that will be importable as ES6 modules and web applications. So there's no real burden on anybody else so you're using Rust, other than maybe maintenance, and those sorts of things are easy to deal with. Thank you, David. I appreciate that. So, thank you, Anonymous. I appreciate that as well. All right. Well, if there are no other questions, again, thank you for your time. Please stay safe. Please come back and visit some other time, and let us know if you do anything interesting with Rust. So, and the video will be available, I think, at some point in the near future. I don't remember exactly what the timing is on that, but you should be able to get back to it.